2017's paper, we have the polynomial given, and when it is divided by this quadratic equation here, we have the quotient and remainder. And now we need to find A. Where is A? A is here, okay? So it means that we need to use this one with the quotient remainder. We can get the whole formula. So this one, dividend times quotient plus is the division algorithm. Okay, so we break the bracket and then group it with the line term. Now by identity, because we have the original polynomial in general form, so we compare the coefficient. The coefficient should be the same for identity. So 14 plus 3a should be equal to negative 13. Okay, we solve a by that. And we finish a part. Do we need to find b and c? This is not mentioned in this question, so you can find it or you can just leave it. Okay, go to b. Let gx be a quadratic polynomial such that when gx is divided by another quadratic polynomial, the remainder is bx plus c. It means that when gx divided by this one, we will have a quotient, but we don't know the quotient yet, so we write qx and then plus the remainder, okay? So that's what we do here. We just let this one into the quotient. We don't know the quotient, so we just write this here. Okay, so fx minus gx, you first show how it looks like. Okay, so this is fx. Why we know that we need to use this format instead of the polynomial in general form? Why we know we need to use this one instead of this one? Because you can see it asks in B1, is it divisible by 2x squared plus ax plus 4? A is negative 9, right? So you can see this one appear in the division algorithm of fx, right? So of course we need to use it in this format instead of using this one. Okay, so first fx here and then gx here. So now comes to the tricky part. After you minus it, you break the brackets here. So after you break the bracket, inside the bracket, the sign need to change because we have minus in front of the bracket. Now you can see that bx plus c, and here we minus it, so they cancel. So b and c, actually you don't need to find it. They cancel each other. What we left is these two terms that you can say already factorized. Okay, by this you can see that when fx minus gx divided by 2x squared minus 9x plus 4, we have no remainder. So we can say it is divisible by the quadratic equation here, okay? Because there are no any remainder. Okay, so B2, someone claimed that all the roots of the equation fx minus gx equals 0 are integers. So all of the roots are integer. We just need to find one, at least one, that is not integers. We can say we are not agree with it. So can you find one of the roots here? Because this one actually you don't know, right? You don't know what is qx. You don't know the quotient here. But you can solve this one, right? You have the first polynomial here. So quadratic equation. How we solve it? We use the formula O1. After you use formula O1, it will successfully further factorize into this 2 bracket. And then you can get one root of 1 over 2, the other one 4. Okay, the other one 4. Since 1 over 2 is not an integer, so we disagree with the answer. Can you find this one? You cannot find the roots of this term because you don't know qx, okay?